was, you know, he was pro-civil rights, very pro-environment.
Did you guys have fun with this video series on the S20P from Marconiphone?
They can go enjoy it. They can
They're
pay
gonna
the real
get
estate
it.
taxes. They're going to get it. They're going to have to get used to
Pretty
paying
cute,
those
huh?
bills anyway, if they plan on keeping it.
Yeah.
So Stephen, the chap from England who sent this radio over for me to work with, I wanted to thank him for sending it and making such an interesting project. There was a lot of torture, of course, involved because this was not an easy project for me because there was so much restoration involved, and a set from the UK using parts and techniques that I'm not used to. So it's been quite a series. But the little set did come back to life, and I was able to restore the plastic using some techniques that I'll be going over in the video. It's, you know, you open the lid, it starts working.
And I don't think you could. I don't know for sure, but the problem
So
with the PLC
it's doing what it's supposed to do.
People you are. Oh, you're spot on, Victor. In other words,
So anyway, it is what it is, and I hope you've enjoyed this video on the little Marconi S20P. This is the original handle, by the way. I didn't do anything with that, but you can do as much as you want to do in restoration with these types of sets. Perfection is possible, and the techniques that I've outlined here could be made to work, but they're probably not the best techniques for a serious restoration. Okay, time for circuit alignment. We need to align the S20P, and I'm looking at the instructions for alignment, and it says a suitable tool for adjustment of the iron dust cores, EMI stock number Q/D5025 is available from the Service Development Division, 100 Blythe Road, Hayes, Middlesex. So the video is going to be delayed some because I'm going to have to send this by post along with the 50 pence, and this tool should be coming within a couple of months, I'm hopeful, and we'll be able to get the set aligned. When doing the alignment, you can certainly follow the directions on the sheet. The Trader service sheet 899 covers the Marconiphone P20B, and you can certainly follow those instructions for circuit alignment for a completely dead set. Work your way from the audio stage back toward the front. But since this radio is basically functional, I'm going to skip some steps and simply connect to pin 6 of V1. You could also hook up to the loop antenna, which would also be equivalent to pin 6 since they're connected on the other side. So one connection from the signal generator to pin 6, or the hot side of the loop antenna, is how we're going to inject IF into the radio. And so we're skipping the step of dealing with V2 first and tuning the last IF transformer. And we're going right to the front of the set, and we're going to align both IF transformers with this method. Step 1, we want to adjust the generator to 365 kilohertz. So let's get that set up. 360 something here. Where are we? 390. Oh, we're getting close. Close enough. Okay, 365 kilohertz, and we'll need a put a tone in. I don't know, 30% modulation. Let's we'll turn on the radio, see if we hear a tone. That's always a good sign. Tells you that the IF's basically pretty close as we start. So back that off a little till we just have a tone that's hopefully in the range of the radio, and now we can start adjusting the IF transformers. So I'm very disappointed. They never sent my tuning tool. I'm going to have to speak with the Hayes Better Business Bureau. I'll be sending a man down there. So we start with the second IF transformer, and we have a L8 and L9, and they're telling us that we want to adjust the bottom one first. So that's going to be this one here. Since I don't have a tuning tool, it's really tough to see what I'm doing. But I have to get in there with my needle nose pliers and try to turn that. Okay, went too far. And we got a little bit of gain out of it. And then you do the top of the transformer. And then again, the bottom of the first transformer and the top of the first transformer. You know, I'm trying the top of the transformer, top of the second. This is really fun, isn't it? Now, as you get more output, keep turning the generator down as you're tuning. Pretty broad, pretty easy to adjust. And then it's always a good idea, once you're done with this IF adjustment, to kind of rock it. So it sounds like, yeah, it's nice single peak. And that's it on the IF. So it was very, very simple. 1.1 mic capacitor to pin 6 of the first stage, V1. Dribble in some 365 kilohertz IF at about 30% modulation. They don't tell you that in the alignment instructions. And then just tune the tone and keep turning the attenuator or your signal output of the generator down, down, down as you tune the two transformers. I did pick up a little bit, especially on the second transformer. The first transformer was pretty broad. Next, I'm reading the instructions, and they're talking about coupling a signal generator output via a loop of wire set up at the bench at a minimum distance of 2 feet from the frame aerial. So there's the frame aerial, and we're going to go up, and here's a loop of wire. Doesn't say how big the loop of wire should be, but it's a nice loop. And we'll see if we can dribble some medium wave and long wave energy down into the loop antenna. Notice that they are in line, because that's the way loop antennas work. They don't work broadside, they work in line. Looks like the loop idea does work. I'm picking up medium wave, and all across the band I can pick up the generator. I did a quick tune, and I can see that the radio tunes up to about 1550 kilohertz, and it tunes below 540 kilohertz, so it's centered towards more of a European AM broadcast band than North America. There's not much you can do with the radio apart like this. You do have to put it back into the front bezel so that the dial readings make sense. Plus, we're pretty much done with the bottom now, so it's time to start reassembling the set to the point where it will allow us to complete the alignment. And next you'll see this assembled together a little bit at least, so we can do some more serious alignment. Now, when you're lowering the chassis onto the panel, the most important thing is to make sure that the band switch mates up with the switch itself. The switch itself has a protrusion that has to go into a little recess that's in the switch. So set that about in the middle, and then kind of fish it in as you're bringing the chassis down, and then test the switch before you actually put on this first nut, which is in the middle. Once you've got that working and you're happy with it, then you can put the 4 outside chassis nuts on. There was a problem with the variable capacitor, and I was able to bend the plate that was the offender that caused the scratchiness. Now we're able to tune the radio with no noise. Okay. So it is time to put the dial all the way in. There it is. The dial is now back in the radio. So I can say the broadcast band was in pretty good shape, actually. It didn't need much touch-up, but the long wave band was way out of alignment. You need a tool that has a pretty strong front on it to adjust the L2 coil, which is up here. The L2 coil is the one that's closest to this side, and that certainly helped to resonate L1, which is the main pickup coil. Also, these 2 trimmers that are on top are the ones that are associated with the tracking on the long wave band, and both of those needed to be touched up. Before I adjusted, I was getting all kinds of crazy birdies and all kinds of bleed-in from the broadcast band, the medium wave band, into the long wave band. Now it seems to have settled down once I got the long wave adjusted. Now, the volume control was horribly scratchy, and I've been able to fix that completely by drilling a very small hole right here and putting in some contact cleaner in that small hole that I drilled in through the seal on the potentiometer, because it was pretty bad. Just need a little bit of contact cleaner in there. Now, another symptom of an old radio that hasn't been used in a long time is a scratchy band switch. And the medium wave, long wave is a little bit scratchy, so I'm going to have to get some contact cleaner in there as well. But notice that it takes a while for the automatic gain control to recover because of the extremely high impedances that we're talking about and the low leakage of the automatic gain control capacitor, because we replaced it with a new unit. It takes a while for the AGC to recover after you switch the band switch. So I don't know if there's anything I'm going to be able to do about that, but it's not a big deal. We're now in the long wave band. Now, there's nothing to be heard in long wave, but it's coming back. Electrically, I think I'm just about done with the set, and I'm going to start to work on the cosmetics a little bit, and then we'll build the battery. Now, here is the lid switch. So the lid switch, of course, when the cover is closed, the radio is off. When the cover is open, the radio is on. So now I've just put the chassis on. Okay, I'm just dropping it right on. And there are 4 more nuts to secure the casting down to the front panel. So I'm putting the nuts in, basically using the nut driver because it's pretty deep down to the chassis. Now the nut's staying in the nut driver because I put a little bit of human spittle on there to keep the nut from falling out of the nut driver. And bingo, we can put the nuts on. So I could pick up, 5 or 6 7 strong stations here in the basement, but it would work better if we were up at ground level. I have an antenna attached to that same loop we were using.
Located at 2188 Candia Road on the massive easy traffic circle in Manchester. WildlifeSportOutfitters.com.
So as you can see, if you couple
Wildlife Sport Outfitters,
you're basically forming a primary on that antenna, so it makes a transformer.
And sell used firearms. If you're looking to upgrade and
Senate Majority Leader Chuck Schumer. Commission Chair Deanne Walker has stepped down, effective immediately, widening fallout.
Okay, this is going to be the old baking soda and super glue trick, and I've cleaned the cracks in the plastic as best I can with alcohol prep, and I can't get the the black out of this, so I'm going to attempt to work some super glue down in there with a little bit of baking soda, build up a little bead, get some strength back into these areas that are damaged, and then I will sand and polish and paint this. So it's an experiment to see if this method of repair is going to work on this plastic. Okay, so I'm making mistakes galore. The biggest mistake, of course, was to use a gel-based super glue rather than the thin, cheap stuff, which is what I should have been using. But I am building up layers and successfully filling in some of these gaps in the plastic. This was a corner piece that was chipped out, and I've built that up, and we'll see how that comes out. So I know some of you are saying, oh, there is no way that I am going to be sanding the top of this thing, but I can tell you, that stuff as a filler, it works very well. And it's just the right consistency to sand flush to the outside of the plastic. I think this might actually work. The outside of the receiver has been prepped with 600 grade finish, waterproof paper. The hard work was done with heavier grade 220, and the bottom looks pretty good. It's in pretty good shape, but the top needed some reconstruction, and this corner, of course, needed a lot of work, and this crack down through here needed work, and this side over here. So there was quite a bit of filler needed to help that. I'm going to leave the logo right on since it's made of metal. Should be able to sand that after the fact, and it should come out okay. We'll see. That's an experiment. So the next step is to put a couple of coats of the Krylon, this satin white chiffon, hopefully will work okay. And then I have a gloss coat to go over it, but I'm going to do that last. Once we get a couple coats on here and see how it looks, then I'll experiment a little bit with finishing it off. This is going to take a couple of days, probably, before I get back inside. Also want to touch up the front panel a little bit. So I would like to find a way to light up the filaments of our battery tubes using the least cost possible. And I know that in your house, in your drawer, that you've got a whole bunch of those little wall wart power supplies that put out 3 volts, 5 volts, 4.5 volts, and so on. So I just grabbed one of those. I grabbed a 5 volt little switcher power supply, and I think this one's rated at 1 amp. We don't need anywhere near an amp to light up this radio. Something like 250 or 300 mils is all we need to light the filaments for these 4 tubes. So I've got the 5 volt power supply plugged in. I've removed a few parts from an old ATX power supply Okay, you have these things around also. You can get some good parts off these, by the way. You can find bridge rectifiers like this. You can find capacitors and transistors and all kinds of diodes. So I grabbed some parts off that. I got a NPN transistor. It's a power transistor. Who knows, it's an NPN of some kind. I took 3 diodes off the circuit. So 3 diode drops is roughly 1.6 volts, 1.7 volts. A 100 ohm resistor, a 4.7 mic cap, and I think this is a 100 mic cap at 10 volts. So we are putting in, should be almost 5 volts. Right, 5 volts from the power supply. Oh, for a load over here, I've got 4 ohms. So that's a pretty heavy load for this. But of course, it's only 1.5 volts we're looking for, so it's not as much current as you think you would have with a 4 ohm load. But going through our simple regulator, we're getting a nice 1.57 volts. So there's a poor man's filament power supply using nothing but junk. Cost $0. It's a well-regulated 1.5 volt supply that will light up this receiver just fine using one of your low-cost 5 volt wall warts. Now for the high voltage, it's really even simpler. We also need to make 67 volts. It's not that critical. We can make 67 volts by using a 24 or a 28 volt transformer and a voltage doubler circuit using a couple of capacitors and a couple of diodes, and you'll have something to run the radio, and I'll give you that circuit. The transformer does not need to be very large, probably a 1 amp transformer, half amp transformer, plenty adequate. Something small like this even for the high voltage. This thing doesn't draw a lot of current. So if you need to order something, get a 24 volt AC, maybe a half amp or a 1 amp transformer, and using the voltage doubler circuit, that will come out to almost exactly 67 volts. We're not taking very much current out of the high voltage, so it's a pretty simple circuit. So the price of this thing comes down to some pretty low money. Just the cost of the 24 volt transformer, probably $12, and maybe another $5 worth of parts, and the rest of it you can steal off an old ATX power supply, and I think you'll be in business. Okay, the next thing that I'm doing is designing my battery, and I've done that with a illustration tool, and now I'm in Photoshop Elements, and I want to print out the battery. But I found that it's 260 millimeters, which is smaller than 11 by 7 type paper we have here in the US. So I've scaled it down to 0.93. And I've got some bright white stiff paper here. This stuff should be good enough to print on, so I'm going to put that in my printer, and hopefully this is going to break the printer, and we will have a nice battery design. Here comes our battery. So again, I'm printing on bright white cardstock, and the printer was able to take that. I wouldn't put too much of that through your printer, but it seemed to be able to tolerate it. So I just want to talk about batteries for a minute. As you know, we're going to be making a battery pack for the little radio. And there's an obvious choice for the high tension, or the HT, or the high voltage, and that is 9 volt batteries. Most 9 volt batteries that are of reputable manufacturer and fresh date have a capacity between 500 and 600 milliamp hours. Okay, so knowing that we have a drain of 8 to 10 milliamps for the HT, 10 milliamps, that simply means that we should have about 50 to 60 hours of battery life. It actually is going to be more than that if you turn the set on and off periodically, because the batteries do recover some. But rule of thumb, 50 or 60 hours on the HT. Now with a D cell, and for the D cell we're talking about lighting up the filaments of the tubes. Most of them are about 12,000 milliamp hours. So, we have let's say we have a drain of 250 mils on the filaments. You can see that we're in the same ballpark of 50 to 60 hours on the filaments. So it's a very good match having a single D cell and a bunch of 500 to 600 milliamp hour batteries in series. So it's fairly apparent that this was probably what the radio was designed to work with, something like that. I, however, want to make a smaller pack that can take advantage of a C cell. The C cell has about half the capacity of the D cell. So in other words, it's going to go dead after 24 hours. So it's not a good match. But knowing that, I can make the battery pack so that it uses a battery holder for the C cell. So I can just keep changing filament batteries and count on the high voltage to stick around for a while. So I usually pay for my mistakes in dramatic fashion, but in making the battery box, I took my nice outline here and I put some thin cardboard stock in there just to stiffen up the bottom a little bit. Now that extra thickness may get me in trouble, but I wanted something for the battery box to rest on with a little bit of stiffness in it. We'll see if that has to come out or not. So the idea is you've taken a piece of aluminum or thin steel and bent it into this shape. You're going to be mounting the connector right on the front here. The C battery goes around in here. There will be 3 stacks of 2 across here and 1. So that's 7 9-volt batteries altogether. Hopefully that will be enough juice to run the radio. So this is the battery box part of the project. Next, a fit check is in order. Let's just say the battery box rests in the radio, something like this. Okay. There it is, it's in. Now the idea is the battery box does stick up a little bit, but of course this is recessed, so with any luck you should be able to close the cover. This is a good fit check. You want to do this kind of before you build the battery. You want to make sure that the battery box does indeed fit. So when you're putting the battery box together, you want to definitely countersink the holes to hold the female connector onto the battery box. Also, make sure there's nothing sharp or protruding on the fit check on the battery frame, and make sure you get this in the right way so that it lines up with the markings on the outside of the battery case. And next we're going to put the batteries inside and get the thing buttoned up and be able to try it in the radio. Ah, not bad, 75 volts. That's a good place to start. for a fully charged. Speaking of which, you could use rechargeable batteries if you could find some of those rechargeable 9 volts. That would be clever. Some old NiCad 9 volts, if they even make them anymore. On the C-cell, I've got some nice... Ooh, these are made in Germany. Wow. I'm going to put one of these C-cells in for the filament. Okay, so the particular battery holder that I'm using for the C-cell is an old Keystone all aluminum design. It's a real vintage piece. Of course, today you would get the plastic ones online to be a better situation, but I had one of these in the box, so I used it. I think it was a double, and I cut it in half and moved the holder over, and as you can see, the positives on this side. This is not a polarized holder. Notice it doesn't have the spring. It uses the aluminum itself to make the spring. But getting very close to firing the radio up on the battery. And the Varta battery providing 1.6 volts unloaded. So did you guys seriously think I was ever going to get this little radio to work and be somewhat pleasant to look at? It happened. It may not be the best techniques of restoration, but it does work. And
Charlie Bergeron.
That's pretty good for instant on, huh? For a battery portable. Not bad. So this is the final video on the S20P from Marconiphone.